Good morning and Sai Ram. This is a part 6 of Is Matter Around Us Pure? In previous video, we have done part 5th of this chapter, and the topics which we had covered is saturated, unsaturated solution, concentration of a solution, effect of heating and cooling on saturated solution, solubility, and physical and chemical change. Let us start with the revision of this part. Let us start with the concentration of a solution. What do you mean by concentration of a solution? Concentration of a solution means that the amount of solute present in the solution. The amount of solute present in the solution is known as the concentration of a solution. If the amount of solute present in the solution is very less, in that case we can say that that solution is your diluted solution, and in simple language you can say that that solution is less concentrated. On other hand, if the solute which is present in a solution is in a large quantity, in that case we can say that that solution is a concentrated solution. That solution is a concentrated solution. So on the basis of concentration, we can divide solution into two types. We can divide solution into two types. Number one, your diluted solution, and number two, your concentrated solution. In dilute solution, your solute present in a very less amount, and in the concentration solution, your solute present in a very large amount. So our next topic was saturated and unsaturated solution. What do you mean by unsaturated solution? Unsaturated solution means there is a capacity to dissolve more solute in the solvent. There is a capacity to dissolve more solute in the solvent. That type of solution is known as your unsaturated solution. That type of solution is known as your unsaturated solution. And what do you mean by saturated solution? There is no capacity. You can't dissolve more solute in that much amount of solvent. Clear? That type of solution is known as your saturated solution. That type of solution is known as your saturated solution. In saturated solution, you can dissolve more solute. But in saturated solution, you cannot dissolve more solute. Now, what is the effect of heating and cooling on saturated solution? What is the effect? See, when you will increase the temperature, the solubility will increase. That means you can dissolve more solute. Take one example. If you will take 1 glass of water and you will add 1 spoon of sugar in it, what will happen? That sugar will dissolve in that water. Add more and more sugar. After some time, that sugar will stop dissolving. That means your solution becomes saturated. Clear? Now, if you will put that solution into gas and if you will apply heat, then you can dissolve more sugar in that solution. That means if you will increase the temperature, you can increase the solubility of the solution. And if you will decrease the temperature, that sugar particle will come out as a crystal. Clear? So if you will decrease the temperature, you can decrease the solubility of the solution. With this information, you can say that increase the temperature, increase the solubility. Decrease the temperature, decreases the solubility. And what do you mean by solubility? Solubility is your amount of solute which you can dissolve in a solvent. That is known as your solubility. What do you mean by physical and chemical change? Physical change are those type of changes in which you will not get any new substance and you will get back to your original state by using any of physical method. Clear? These type of changes are known as your physical changes. For example, if you will add sugar and sand, or sand and sugar, salt and water, these you can separate out by using any of the physical method. So these are your physical change. Clear? By the help of evaporation. Clear? What do you mean by chemical change? Chemical changes are those changes in which you will get a new substance. Chemical changes are those changes in which you will get a new substance and you will not get back into your original state by using any of the physical method. For example, preparing of chapati. These all are the example of your chemical change. With this, we have done our revision part. Now we are going to start the part 6 of Is Matter Around Us Pure. The topics which we are going to cover is by using a suitable solvent, by the process of sublimation, by using a magnet. How you can separate a mixture of solid and solid. There are 3 ways by which you can separate out a mixture of 2 solids. What they are? Number 1, by using a suitable solvent. Number 2, by process of sublimation. And number 3, by using a magnet. So all the mixture containing 2 solid substances can be separated out by one of the following method. And what they are? Number 1, by using a suitable solvent. Number 2, by using a sublimation process. And number 3, by using a magnet. Now we will describe all these methods by separating solid mixture in detail one by one. So your first method is separation by a suitable solvent. Your first method is separation by a solvent method. Sorry. See, the solubility of all the constituent is different in all the solvent. Clear? Take one example. If you will take sugar and mixture of sand, you will take a mixture of sugar and sand and you will take water as a solvent, what will happen? We all know that sugar is soluble in water and sand is insoluble in water. So this difference in the solubility of the constituent of a mixture can be used to separate them. How? A mixture of sugar and sand can be separated by using water as a solvent. Now I will explain how. Sugar is insoluble in water whereas sand is insoluble in water. This is done as follows. What you will do? You will take a beaker. In beaker you will add sugar and sand. Clear? After some time, after mixing it properly, what you will add? You will add water to it. See in second step. What you will add? You will add water in the mixture. Clear? And you will stir with the help of stirrer. Now you will take a funnel and you will put filter paper in the funnel and you will pour this solution to the funnel. What will happen? Yes, your sugar will go down with the water and sand will remain in the filter paper. So with like this you can separate out a mixture of sugar and sand by using suitable solvent. And what is a suitable solvent for this mixture? The suitable solvent of this mixture is water. Clear? I'm reading. Listen carefully. The sugar solution containing sand is filtered by pouring over a filter paper kept in a funnel. Sand remains as a residue on the filter paper and sugar solution is obtained as filtrate out in the to get the crystal of sugar. The sugar solution is evaporated carefully to get the crystal of sugar. In this way you can separate out sugar and sand by using water as a suitable solvent. With the same method you can separate out the mixture of salt and sand with the using same solvent as a water. What you will do? You will take a mixture of sand and salt. In second step you will add water and stir with the help of stirrer. And you will take a funnel and the funnel you will add the filter paper. You will put the filter paper and pour the solution into the funnel. What will happen? The salt will come out with the water and sand will remain as a residue on the filter paper. Like this, you can separate out the mixture of sand and salt. Now take one another example in which you will take what? Carbon disulfide as a solvent. What you will take? You will take solvent as a carbon disulfide. Here, what you will do? You will take a mixture of sand and sulfur. As we all know that sand is insoluble in carbon disulfide and your sulfur is soluble in carbon disulfide. You will add carbon disulfide as a solvent into the mixture and you will stir with the help of stirrer. Same procedure. You will take a funnel. In funnel you will put a filter paper, pour that solution into the funnel. What will happen? Sulfur will come out with the carbon disulfide and it will collect in the beaker and your sand will remain as a residue in the filter paper. Evaporate it, you will get sulfur. Clear? So like this you can separate out sulfur and sand by using carbon disulfide as a solvent. Clear? So it is not compulsory that in every case you will take same solvent. Solvent depends upon the solubility. Clear? Some substances are soluble. See, you can't separate out salt and sugar by using water as a solvent. Why? Because both sugar and salt is soluble in water. Clear? See, this is a picture of carbon disulfide, sulfur and sand. Sulfur is yellow in color. What is the symbol of sulfur? It is S, capital S. Clear? Now our next method is separation by sublimation. Our next method is separation by sublimation. We have already studied the process of sublimation in the previous chapter. Clear? We have already done. What do you mean by sublimation? Yes, the meaning of sublimation is the changing of solid. The changing of solid directly into vapors on heating. The changing of solid directly into vapors on heating and directly solid into vapor is known on cooling is known as sublimation. That means if you will apply heat to any solid substance and if it is converted directly into gas, that process is known as sublimation, and that vapors that on cooling that vapors is directly converted into solid, that process is known as your sublimation. Clear? And the solid substance which undergoes sublimation is said to be sublime. What they are called? They called as a sublime. What are sublime? Sublimes are those substances which directly converted into vapors on heating and that vapors directly converted into solid on cooling. So these substances are known as sublime. Now the process of sublimation is used to separate those substances from a mixture with sublime on heating. You can use sublimation as a separation technique only when you want to separate out a sublime substance. What you want to separate out? You want to separate out a sublime substance. Clear? And the solid substance obtained by cooling the vapor is known as sublimate. If you will cool that vapors, and whatever substance you will get, that substance is known as your sublimate. Clear? So what are the example of sublime? Yes, the example of sublimes are your ammonium chloride, iodine, camphor, naphthalene, anthracene. They all are the example of sublime. That means if you will heat these substances, they will directly convert it into vapors. And if you will cool down these vapors, they will directly convert it into solid. Clear? This means that ammonium chloride, iodine, naphthalene, camphor, anthracene changes directly from solid to vapors on heating and from vapors to solid on cooling. Tell me, what is the formula of ammonium chloride? Tell me fast. The formula of ammonium chloride is NH4 Cl. Clear? The formula of ammonium chloride is NH4Cl. Now, this is a picture of ammonium chloride. Second one is iodine. Third one is camphor. Fourth one is naphthalene. And the last one is anthracene. Clear? And the last one is anthracene. Number 1 is ammonium chloride. Number 2 is iodine. Number 3 is camphor. Number 4 is naphthalene. And number 6 is anthracene. Clear? Now, how you will separate two solid mixture by using sublimation as a separation technique. Now, take an example of common salt and ammonium chloride. As we all know that ammonium chloride is a sublime product. Clear? And your salt does not sublime on heating. So, if you will take a mixture of you can say ammonium chloride and salt in a china dish, and you will put, see in the figure, and you will put inverted funnel on that. Clear? And you will cover that open end with the help of cotton plug, and you will apply heat to that mixture. What will happen? After some time, the vapors of ammonium chloride will comes out, because that ammonium chloride will not convert into liquid state. It will directly convert it into vapor state. So after some time, when the vapors comes out, that vapors will strike with the side wall of the funnel, and it will stuck over there. When you will cool down the temperature of vapor, that vapor of the ammonium chloride will directly convert into solid, and you will scratch out that salt with the help of spatula, and you will collect on the some another dish. So what will remain in the china dish? In the china dish, common salt will remain, because all the ammonium chloride will come out in the form of vapor. Clear? And it will stuck on the side wall of the funnel. Clear? Now I'm reading this, listen carefully. The mixture of common salt and ammonium chloride is taken in a china dish and placed on a tripod stand, and china dish is covered with an inverted glass funnel. A loose cotton plug is put in the upper open end of the funnel to prevent the ammonium chloride vapors from escaping into the atmosphere. Clear this thing? I have already explained to you. Now the next one is, these vapors rise up and get converted into solid ammonium chloride on coming in contact the cold inner wall of the funnel. In this way, pure ammonium chloride lets come on the inner side of the funnel in the form of sublimate and can be removed. Common salt does not change into vapor on heating, so it's left behind in a china dish. Thus, a mixture has been separated into two components of ammonium chloride and salt. Clear? Like this, you can separate out the mixture of ammonium chloride and salt. Clear? The next one is separation by using magnet. The third technique is how you will separate a mixture by using magnet. See, iron is attracted by a magnet. We all know that. Clear? So with this separation technique, you can only separate out a mixture which is having iron as a one of its constituent. Clear? Now, iron is attracted by a magnet. This property of iron is used to separate it from a mixture. So, if a mixture contains iron as one of the constituent, it can be separated by using magnet. That means if you want to separate a mixture by using magnet, that means that mixture should contain iron, and you can separate only what? You can separate only iron. Clear? See, for example, a mixture of iron filings are attracted by a magnet, but sulfur is not attracted by a magnet. The first picture is a magnet, second one is iron and sulfur. If you will take a mixture of sulfur and iron, what will happen? If you will take a mixture of sulfur and iron and you will use magnet, that all the particles of iron will attracted towards a magnet, and what will remain? Sulfur will remain as it is, because sulfur will not attracted by magnet. So like this, you can separate out what? you can separate out a mixture of iron and sulfur by using magnet. Now, how it's done? In order to separate iron fillings from a sulfur powder, a magnet is moved on the surface of the mixture. The iron fillings are attracted by the magnet and get separated. This process has to be repeated a number of times to achieve complete separation of iron filling. Sulfur powder is not attracted by use of magnet. So that means if you want to use a separation technique by using a magnet, that means in that case, I'm saying again and again, iron should be there. Clear? See, in this photograph shows a iron containing material being lifted up by electromagnet attached to a scrap crane to be separate from other metal scrap in a factory. So with this we have completed how two solid mixture can be separated out. There are three ways by which you can separate out a mixture of two solid. Number one, by using a suitable solvent. Number two, by using sublimation. And number three, by using magnet. Clear? In all the separation technique, you have to remember some points. That means in first technique, you have to remember that which solvent is suitable. That means if you for example, if you will take water as a solvent and you want to separate out a mixture of salt and sugar, you can't separate. Why? Because sugar and salt both are soluble in water. Clear? And in second process, by using sublimation, sublime product should be there. If that substance is not sublime, that will not, you can't separate out that mixture. Clear? And in the third one, what's your condition? Iron should be there, and you can separate out only iron. Clear? I think with this everything is clear to you. Still, if you are having doubt, you can message me and you can ask anytime. Thank you and Sairam.